Assalamualaikum and hi again everyone. Now moving on to the calculation on partition coefficients. I already introduced to you what is partition coefficient. So let's take a look on the first example. Now in the first example, it is a solutions of P. So P here is your solute, the molecules. In water was shaken with some benzene. So water and benzene here is your solvent. Now the concentrations of P in both solvents were measured. Here the concentrations of P in water were 0.001 mole per dm cube, and the concentrations of P in benzene is 0.02 mole per dm cube. Our question is calculate the partition coefficients of P between benzene and water. So let's take a look into the diagram. So you have here P, which is your solute or your molecules. This one is in benzene and the other one is in aqueous or in water. And make sure that these two solution, benzene and water, they are immiscible solvent. Now the data given is that the concentrations of P in benzene is 0.02 mole per dm cube, and the concentrations of P in water is 0.001 mole per dm cube. Make sure that these two concentrations have the same unit. So what do? We just plug in into the KPC expression. So here concentrations of P in benzene divide by the concentrations of P in water. Now how do I know benzene should be on top? From the question itself. It says between benzene and water. So benzene first, it should be on top, and water will be down below. Therefore, when you plug in the value, it will be 0.02 divided by 0.001, and it is equal to 20.0 value-nya, KPC. So remember, this KPC, you have to give me the value in 3 significant figures, and make sure that you know there is no unit because these two have the same unit. And also another one that I have to mention is that make sure the unit of the concentration between this are the same. Mole per dm cube, or maybe gram per cm cube or gram per dm cube. Now another one that I have to emphasize here, never ever write down your KPC formula in this format where you just put the concentrations of benzene over the concentrations of water. Now here you can see that why is this wrong, because the one that we're looking for is the concentrations of P. So it's the molecules of P that you have here. Okay, therefore it's a total X. You cannot write down in this formula. There is no P in that formula. Now moving on to the next one, example number 2. Now this one is a bit harder, a bit saja. Now what happened here is that you have 2 grams of R, and it is shaken into a mixture of 100 cm cube of hexane and 50 cm cube of water. R here is your solute. Okay, and then here you have the hexane and water, which is your solvent. Okay, and here after you reach equilibrium, there are 0.4 grams of R in water. Calculate the partition coefficients of R between hexane and water. Here I have the diagram. So you can see here R is your solute, which is in hexane, and then here you have R in aqueous water. And make sure that between hexane and aqueous water, these two solvents, they are immiscible. Now, given in the data, you have 0.4 grams of R in your water. Therefore, you can find the concentration. Concentrations of R in water will be 0.4 divided by 50, which is equal to 0.008 grams per cm cube. And you do realize that the unit here is not mole per dm cube. I'm using gram per cm cube. It doesn't matter what concentration unit that you use as long as both of the concentration have the same unit. Now, how do we find the concentrations of R in hexane? So here's the answer. First, you have to know how much R dissolved in your hexane. So 2 grams is the total mass of R. It's given here. And then the 0.4 is the mass of R in water. Therefore, when you minus 2 minus 0.4, it will be equal to 1.6. So this 1.6 gram is the one that dissolved in your hexane. What's the volume of hexane? 100 cm cube. Therefore, the concentrations of R in hexane will be 1.6 divided by 100. So here I have the concentration of R in hexane, which is 0.0160 gram per cm cube. And you do realize here the unit of the concentration is the same. Gram per cm cube, this here also gram per cm cube. Next one is to find the KPC. So it's the concentrations of R in hexane divided by the concentrations of R in water. How do I know hexane on top? Is because from the question, it's given that hexane first and then water. So hexane should be on top, water should be below. The value of R in hexane is 0.016 and the value of R in water will be 0.008. So if you divide these two, it will become 2.00. Again, make sure 3 significant figures and there's no unit for KPC. And you have to make sure these two have the same unit for the concentration. I'm using gram per cm cube. Now, done with that, let's move on to a harder one. This one, I would not give you the value of the concentration. Okay, instead, you have to find it out using titration. So, bear with me with this. Now, I have a solutions of iodine. Okay, so your iodine here is the solute, the molecules, in tetrachloromethane CCl4. So, this CCl4 is one of the solvent. Now, it was shaken with water. So, water here is another solvent until equilibrium was established. And then the two layers were allowed to separate out. Now, for the first one, when you separate these two mixture, okay, these two solvent, you take 25 cm cube of the sample of the lower organic layer, which is the CCl4, and then you titrate it with 0.1 mol per dm cube sodium thiosulfate. Now, why are we using sodium thiosulfate? Because sodium thiosulfate will react with iodine. I will show you the equation later. Now, here, when you titrate your organic layer with sodium thiosulfate, remember, it will react with the iodine, not the CCl4. Okay? And this titration requires 21.4 cm cube of sodium thiosulfate. Now, another one is that you do the same thing with your aqueous layer. You take 25 cm cube of the aqueous layer and then you titrate it with sodium thiosulfate. But if you do realize, here I'm using a lower concentrations of sodium thiosulfate. But still, I'm using sodium thiosulfate because it will react with the iodine. Okay? Now, for this titration, it will require 25 cm cube of the solution. And the same question, we are looking for the partition coefficients of iodine between the tetrachloromethane, which is CCl4, and water. So let's take a look on the diagram. Now, when you mix the two solvent, CCl4 and water, and you shake it, the iodine will reach equilibrium. So you can see here at first, before you shake it, most of the iodine is down there. The iodine molecules is the black dot here. Once you shake it, some will go to the upper layer and the other will be staying in the lower layer. But remember, this iodine can goes up, the other can goes down. It keeps on doing that because they are already reaching equilibrium. Next one, you separate these two solvent. Okay, the CCl4 and the water, you separate it into two different conical flasks. I have here the first conical flask is the one that I collect for CCl4. The other one is for water. Now, once you already separate these two conical flasks, then you can do the titration. So, what you do is that you take 25 cm cube of this CCl4, you put it into another conical flask. So, I'm taking 25 cm cube of the CCl4. Now, remember, this CCl4 aqueous here, no, not aqueous, CCl4 layer, it contains iodine. That's why I'm titrating it with sodium thiosulfate. Now, for this sodium thiosulfate, you are using 0.1 mol per dm cube concentration and the volume required is 21.4 cm cube. Next one, you do the same thing with your aqueous solvent. You take 25 cm cube of that and you put it in this conical flask. Next one is that you titrate it with sodium thiosulfate. the concentrations of sodium thiosulfate here is 1 times 10 negative 3 mole per dm cube. And for this titration, you require 25 cm cube of this sodium thiosulfate. So from here, you already have the data that you require. You have the concentration, you have the volume for the sodium thiosulfate. So our next job is to find what's the concentrations of iodine inside this CCl4 and what's the concentrations of iodine in this aqueous. Now, to find the concentrations of iodine inside this solution, this CCl4, first you find the number of mole of sodium thiosulfate. Concentrations times by the volume. You get 2.14 times 10 negative 3 mole. How do I get the number of mole of iodine? So, 1 mole of iodine requires 2 mole of sodium thiosulfate. So, whatever number of mole that you have here, you divide it by 2. Then you get 1.07 times 10 negative 3 mole. And finally, you can find the concentration. Number of mole divided by the volume. What's the volume of the CCl4? It's 25 cm cube. Then you will get 0.0428 mole per dm cube. So this will be the concentrations of iodine in CCl4. Next one, you do the same thing to the aqueous layer. First, you find the number of mole of sodium thiosulfate that you use for titration. So concentrations times by the volume. The volume here is 25. And then it is equal to 2.5 times 10 negative 5 mole. Next one, do the same thing. 1 mole of iodine requires 2 moles of sodium thiosulfate. So here I have number of mole divided by 2, which is equal to 1.25 times 10 negative 5 mole. And finally, you find the concentrations of iodine in aqueous. Number of mole divided by the volume. The volume here is 25 cm cube. So you will get 5.00 times 10 negative 4 mole per dm cube. So from this calculation, you already figure out what's the number of mole, what's the concentration, in CCl4 and also the concentrations of iodine in aqueous. And after that, you can answer this question, the partition coefficients of iodine between tetrachloromethane and water. Kpc is equal to concentrations of iodine in CCl4. Why CCl4 on top? Because you mentioned tetrachloromethane first before the water. Then you divide it by the concentrations of iodine in water, which is equal to 0.0428 divided by 5.00 times 10 negative 4. Then you will get 85.6. And remember, these two concentration must have the same unit. Here, I'm using mole per dm cube. And for your final answer, make sure it is 3 significant figure. And since Kpc is a ratio, again, there is no unit. So that are the 3 examples on how you do the calculation on Kpc. I hope you do watch this video and then go do your assignment that I will upload tomorrow.